Good afternoon. Thank you for coming, and thank you for the invitation from Delta to give this talk. A quick introduction to RED, just for those of you who don't know who I'll be very quick, and then I'm going to talk about energy transition, the drivers of zero carbon data centres, emerging trends and technologies that might help us get there, and then a section on data centres and small modular reactors and how nuclear might be part of the energy transition as we move forward. So a very brief introduction to RED. So we were founded 20 years ago in the UK. We're now close to 800 people globally, and we operate all around the world with the exception of North America, really. And we are a data centre specialist design consultancy. We've designed over 1,000 data centres during those 20 years. So energy transition is the move from the reliance on fossil fuels to renewable fuels and ways of generating our energy. It's the growing use of renewable energy sources, and it's involving continuous innovation and new technologies. But as well as renewable energy, we're going to be very key to think about the shorter-term grid stability and actually meeting the energy demand that we won't be able to get from just purely renewables to keep up with the rate of growth. So, who remembers a life before a mobile phone? Having to turn up on a date, at a time, at a venue you'd arranged 2 weeks before with no get-out-of-jail-free card, of phoning up 10 minutes before and saying, "Oh, so I'm running late, I'll see you half an hour later." You know, it's quite amazing how the world's changed. But more importantly, in terms of data centres and energy, is how phones are developed. You know, better processors, better cameras, better screens, better connectivity with 3G, 4G, and now 5G and even 6G being coming online eventually. That has really driven the use of social media, streaming of videos, and playing mobile games. And that's one of the things that has driven the uptake in energy consumption from data centres. As you can see, it's growing exponentially, as this graph indicates. So the big elephant in the room is, where does all this green energy come from? Actually, where does all the energy come from, let alone the green energy? So data centres are responsible for 3% of the global emissions. That's 50% more than the aviation industry. And to put that in perspective, the aviation industry uses a billion litres of fuel a day. And data centres are 50% more than all of this, and predicted to almost double by the end of next year. So really, as designers, operators, suppliers to the data centre industry, we have an important role in mitigating the impact of this and the effects it has on not just the environment, but people's lives, as you've seen by the extent of the storms that have happened in parts of the world over the last few years that are linked, most people say, to global warming, which is linked to man-made fossil fuels. So, in Europe, they have come up with the EU Green Deal and some legislation that people in law have to follow. And these cover things about energy efficiency for data centres, the use of renewable energy, water conservation, circular economy, and heat recycling. So the question is, Europe have done this. Will other countries and regions follow? Will we find in Asia countries doing something similar that makes it legislation that we have to start thinking about this rather than just doing it because it's the right thing? And then 100 operators in Europe have come together with a pact to help deliver the Green Deal for data centres. And the question is, these operators, a lot of them work globally. Are they going to start doing this in other regions like Asia, even if there isn't a regulatory or legal requirement to do so? How do we help get to zero carbon at a building level for a data centre? It starts with good design, reducing energy efficiencies where we should start and making things as efficient as possible. And then sometimes the bit that gets lost is, especially as designers, you've designed a building, it's built, it's commissioned, day one it's working as it should do. But do we go back and actually assess if it's still working how it should do in 6 months' time, a year's time? Do we learn the lessons from those designs and how the building is operated, and then feed that back into the design cycle to make continuous improvements? Definitely, and that's not just data centres, that's the whole of the construction industry. Don't do that as well as they should do, and that's something that I think will be key to helping us drive improvements. So is there a roadmap for making data centres zero carbon? Well, I've talked briefly on the previous slide about efficiency and good design, and part of that using digital modelling and even AI itself to help make improvements, DSIM packages, digital twins. But then outside of the data centre, then what else can we do? Can we use the waste heat from the data centre? Can we feed that back into the community? Maybe not easy in a tropical climate like Singapore, but it's something that is practiced in places like Scandinavia. Can we make it part of a high availability microgrid as well to maybe help address some of the problems with power generation for the community? And then we need to look at energy storage, grid stabilisation, and zero carbon backup power, and how we might achieve that. So, trends and technologies. There's been a lot of talk over the last few years about liquid cooling and the adoption of liquid cooling. And AI maybe has brought this further to the forefront because of the high densities involved in AI deployment. But liquid cooling, even if it wasn't for AI, would have advantages in terms of energy efficiency. You can get an increased IT load. You can remove more heat from liquid. Liquid can carry more heat than air, so it's more efficient. You can get better waste heat recovery as a medium than trying to capture it from air. It reduces water usage, which is another key issue the planet has at the moment. And it can work in harsh environments. So yeah, some of the advantages of liquid cooling I've mentioned: more heat efficiency, higher density applications, less water usage. But some of the challenges are maybe a higher initial capex cost for the IT equipment, a lack of knowledge of how the liquid cooling servers work, a lack of experience for the maintenance teams, new training, also the issue of trying to retrofit into an existing facility. Some of these liquid racks weigh a lot more than a standard rack, so can your building structure take the loading? Is there enough space? And although this doesn't particularly talk about AI, when you start looking at AI and the higher loads at 150 to 200 kilowatts a rack, as opposed to the 10 to 20 that you might typically design for at the moment, you start looking at a lot bigger electrical infrastructure to serve your building and a lot more IT infrastructure, which means actually in an AI building, it doesn't get smaller. It stays about the same size. Your floor to ceilings go from sort of 7 metres clear to 9.5 metres clear to allow for all the infrastructure over the top of your racks. So there's a lot of balancing to be done. And then energy storage systems. So as we look to transition to renewable energy, part of the problem with renewable energy, such as wind and solar, is it's not very stable. So how do you cover those periods when the wind stops? So you need to have some form of energy storage, whether that's batteries, fuel cells, flywheels, supercapacitors. So that's something that, again, needs lots of research and development into people to come up with the right solutions that are cost effective and can be mass produced. And then you're looking at fuel generation and how you might use the fuel. So you talk about hydrogen, you talk about fuel cells, you talk about gas engines as opposed to diesel gensets. And again, future green fuels. There's a lot of choice, potentially, and no one knows who will win the race or whether there will be multiple different fuels, and it will depend in which country, region you're operating, which one takes the preference. Biofuels are produced from biomass. That's biodegradable, clean-burning fuel, and can be nearly 100% carbon-free. Not quite fully. Hydrogen, there's lots of different types of hydrogen, 9 types of hydrogen, all given a different colour, but it can only be truly green hydrogen if it's 100% generated by renewable energy. And then ammonia is quite interesting because liquid ammonia actually contains twice as much hydrogen as liquid hydrogen by volume. So potentially that's a way of transporting hydrogen more safely than transporting hydrogen itself and then converting it into hydrogen. But also ammonia can be burned directly as well. So in the future, it's going to be important to understand how you can make a data center give back, not just take. So some of the ideas are that the data center sits at the center of a microgrid. So on one side, you have electrical supply distribution coming from many different sources, the grid, renewable, so it could be solar, it could be biogas, it could be H2, could be nuclear. And on the other side, you have the waste heat out from the data center that goes to feed the community, whether it's district heating systems, whether it's processes in industrial plants that need heat, whether it helps with agriculture. So again, it's maybe starting to think about where we locate the data centers. Do we stick them all in an industrial park in the middle of nowhere where there's nothing else around? Or do we look to find a way of integrating them where they could add a benefit? So on the network side, so most data center operators, in fact, all data center operators probably, do not want to be in the world of power generation. So this opens up a new potential market for people to come in as third parties who want to design, build and operate an energy network, shall we say, and take that CapEx off and the operational risk off of the DC operator, sign up to the same SLAs, provide them a tier 3, currently maintainable grid-supplied power, but also, as well as power, with generation of electricity, you get a lot of waste heat. So by using absorption chillers or gas-driven chillers or some other sort of technology, you can capture that heat and also provide cooling as a service to the data center. So you can take all of that off of the data center as well and provide eventually a green energy solution, because what might run on natural gas now can be repurposed to run on hydrogen or biofuels later when they're commercially viable and there's a good infrastructure for delivery. Yeah, so this talks about the thermal side, connection to geothermal loops, bodies of water, just different ways of providing that cooling. We've looked at some studies in Singapore for seawater cooling. It sort of works, not as well as it would do in a cooler climate, but actually surprisingly it demonstrated to potentially be viable, which I didn't think it would have done at the start of the study. So, future of nuclear energy. This might be quite a controversial topic. So, well, start with data centres. Data centres are starting to get a bit of a bad press recently. They're seen as taking resource and not giving back. They're seen as offering very little employment compared to other potential uses for the land. There's also the political social side of things where people see them as uncontrolled spaces that maybe help people proliferate hate speech and misinformation, as you see when you look at things like the elections in the UK at the moment and America. How much of the stuff online is true? How much of it is checked and verified? And nuclear has an even worse reputation, potentially because of the historical events like Chernobyl, Fukushima, and I suppose the overhang from the end of the Second World War. And again, people don't necessarily see the distinction between the civil use of nuclear and the military use of nuclear. But there's been a change of people's, or at least government's thinking recently. So, for instance, the UK government is now committed to try and have 24 gigawatts of nuclear power by 2050 to help meet its zero carbon targets. And other countries in Europe are following suit, and in America. And even Singapore is reconsidering it as a potential solution, A, to the carbon pledges, but also for the current dependence on other countries for all of the energy supply that Singapore uses. I know in 2004 there was initial discussions that basically public sentiment put to bed pretty quickly. It was re-looked at in 2012, and they actually did a study and then discounted it because the blast radius would have hit the CBD. However, we'll see later, the technology has moved on from those days, and potentially the risks are a lot more palatable. So, what's the synergies between small modular reactors and data centers? So, as you can see from here, there's a lot more energy in a nuclear reaction, the nuclear fuel, than there is in any other type of fuel by volume and weight. It's actually 100,000 times more energy from a nuclear reaction than there is from the combustion of a fuel. So, and then recently there's been some licensing and financing in the US, and it would appear they're on track to have some small nuclear reactors operational in the United States of America within the next 4 to 5 years. So these things are now getting to the point where they are becoming viable and seen in certain places as a safe way to help with the energy transition, because they are zero carbon in terms of the fuel. Other issues with what you do with your waste, but in terms of our immediate issue with zero carbon, very good. And we know that data center operators like Digital Reality and Microsoft are investing in these sort of topics, either some in terms of deploying things like small nuclear reactors, others in the case of actually purchasing nuclear power rather than just renewable power. So, as we talked about earlier, the growth of data is going exponentially. And also, when you come to deploying a data center, your ramp up is in quite small stages. So 2 megawatts, 10 megawatts, to get up to your final 100, 300 megawatts on your campus. So small modular reactors can scale quite quickly in line with how the DCs want to scale. So you can match your load with your deployment. Architects are amazing, aren't they? They don't think. So MMRs can start at 10 megawatts electric. So you can conceivably see how you could scale up in chunks of 10 megawatts next to a data center campus or a group of data centers. And then when it gets to a certain size, you would go to the next size, which might be a 300 megawatt reactor. But the other thing about these reactors here is that they have lots of byproducts of heat. So again, you can use that waste heat in the community. So to try and give you an idea of the cost, so an SMR construction cost could be as low as $3,000 per kilowatt. So a 300 megawatt project might cost $900 million. But compare that to something like Sizewell C in the UK, which is a big traditional nuclear plant. For the same 300 megawatt project, that's costing nearly 30 billion. So you can see that these type of small scale deployments, because they're simplified, they're scalable, can be mass produced, shall we say, then they can bring the price down to make them more economic. So it's back to how energy transition fits into this. We are seeing curbs on new DCs in lots of countries. So not just Singapore with the moratorium, Holland, Ireland. Ireland has actually been rejecting new DCs recently on the basis that data centres are predicted to take up 36% of the island's national grid's electrical supply by the end of 2026. And they're not alone. Many grids will not be able to handle the emergence of AI and the power that we will be demanding from them to running data centers. Because energy consumption from data centers is predicted to double by the end of 2026 globally. So at COP28, there was big discussions on nuclear energy as the potential solution for clean energy globally. And 22 countries pledged to triple their nuclear power capacity by 2050. And there's lots of discussions about how these countries will work together to help bring the technology forward so that can be delivered. This is a very simplified diagram, but our parent company, Tractebel, have been doing research into small nuclear reactors for the last 3 or 4 years, as to see their background is in nuclear energy. They run nuclear power plants, build them in Belgium, France. And their view after doing 3 or 4 years of research is that they think that these sort of technologies will become a cornerstone of how we move to net zero over the next 30 years. Not just because of the fact they can produce power, but because they can produce waste heat for heating in communities. They can balance out the intimacy of renewable powers. They can help water scarcity problems that countries are facing because they use less water. They can produce hydrogen and e-fuels, which can help with agriculture and aviation. And they can also then provide process heat for industries. So, conclusions. There's a conflict between the exponential growth in data that we're using as a society and the way that we like to live, and energy demand, and the zero carbon targets. If you look at these countries here, Singapore, it's got stringent targets to meet by 2050, but is expected to have a growth in data centers and energy. And the same will go for nearly all those countries on those lists. Malaysia, as we're seeing in JB, has a ridiculous growth in data centers at the moment as everyone's transitioned from Singapore, where they can't build, to JB. And they've got to find a way to produce this power, and hopefully green power. How do we get there? And it's a long-term partnership between industry, designers, investors, the different technologies. We won't solve the energy transition issue just with renewable energy, just with nuclear, just with good design. Everyone has to come together to work on this problem and find the solution. And back to Singapore. So Singapore have just published the latest green data center roadmap, promising 300 megawatts of IT over the next couple of years. But they've also then said there could be more. But that's more if you can use green fuels, green energy. So they sort of listed out bioenergy, fuel cells, ammonia, integrated building PVs, which might run the fans in the toilets, the data centers, but a little bit. But they're also looking at nuclear again. I mentioned earlier, but in the budget, it was clearly stated in the budget, they're investing money, Singapore, in research and development into nuclear as a potential way to solve their zero carbon goals. But possibly for someone like Singapore, more importantly, is not the zero carbon, it's energy dependency and not being reliant on having a good relationship with your neighbours, not having the risk of someone deciding they want to charge you twice as much for the energy just because they can. Thank you. I'm open to questions.
Let's give him a big round of applause, ladies and gentlemen. Mr. Darryll Howell right here for RID Engineering. Anybody for any questions at the moment? I think we have a person right across over on my right side.
With the cost of power for just developing for one site, that might not make sense. But is anybody talking to you about like building a large power production facility that would maybe supply the gap that is there?
I think the problem you have is operators are sometimes nervous about connecting to shared systems. So there is that issue. We are looking at a site in Japan that may be a gigawatt of IT with half a gigawatt of on-site generation for a campus. But again, until our client goes to the market and starts seeing the interest, we won't really know whether the operators are interested in taking one building or the one site, or even connecting to it. They might decide, no, we don't want to connect to that. We want to keep it off the grid or have our own on-site backup generation and so on. So you don't know. We've had some discussions with the URA here about how you might integrate data centers in the community. So it's not quite the same, but it's about how you might position a data center so that it can export its heat, can provide maybe some power that can cover some of the downtimes and so on.